Hey, so if you take a look, we are going to go to art class, go to our assignments, and we're going to be starting chapter 9 today. Um, it's going to be called 9-01, squaring and square rooting. So I want you to go ahead and open the assignment and get the notes, okay? Make sure it's in Notability. It should look like this. We'll go ahead and move over to Notability because I already imported it. Okay, so let's get started. If you need to pause, you can pause. So squaring and square roots, we're going to be talking about, well, we've been talking about exponents, okay? And I'm going to be teaching you right now that squaring is when we have the exponent to the power of 2. So a perfect square is a phrase we're going to be using for when you have the answer or the result of squaring a whole number. So here are some examples. 2 is a whole number. So 2 squared, does anyone know what 2 squared is? This means 2 times 2, the answer is 4. Okay. 3 squared, and I want you to notice that 3 is a whole number. So that's 3 times 3, and that's going to equal 9. So a perfect square just means that when you square a whole number, 2, 3, 4, they're all whole numbers. They're not decimals. They're not, they're not fractions. They're whole numbers. So 4 squared is 4 times 4, which is 16. Okay, this is 4 times 4. So this is what we call perfect squares. Once we know our perfect squares, you'll be able to know what square rooting is. So it's very important that you understand that a perfect square is just when you have a number, a whole number, and you multiply it by itself. Okay? So here we're going to take a look. Before actually we get into this portion right here, the opposite of squaring, we're going to take a look and get all the perfect squares. So 1 squared is 1 times 1, which is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. If you know it, try to do it on your own. 6 squared is 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. And 10 times 10 is 100. So up to here, this is just basic math facts. If you look at a multiplication table, it's going to be going from the top down and diagonal from the top. Okay, so now this is where it gets a little bit tricky, but what I want you to do is at least memorize up to here. Okay, up to 15 squared, because these are squares that we're going to need to, oh, it's too big. Just want to make sure you can see it. Okay, so we'll keep writing them. I want you to memorize these. 11 squared is 11 times 11, 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And 15 times 15 is 225. So these are perfect squares. I'm going to keep going, but I want you to memorize at least up to 15. Okay? 16 squared is 256. 17 times 17, or 17 squared, is 289. 18 squared is 324. 19 squared is 361. And 20 squared is 400. Okay. So here, this is a list of perfect squares. I want you to get comfortable with these numbers and see these numbers and be like, oh, I know that that's a perfect square. Okay? Because once we know our perfect squared, we'll be able to know what the opposite of squaring is. So go ahead and take a look over here. The opposite of squaring is called the square root. Now, some of you might have seen this before. This little caret. Oh, that's way too big. Okay, this little caret. And then it looks like a division sign. Okay, so this right here, what I just highlighted, is called a square root. Okay, I know this is kind of weird, but I would like you to just say it like we would say it in class, because the more you say it, the more you'll recognize it and it registers in here. So here, this is called the square root, and the square root is the opposite of squaring. So since 6 times 6, or 6 squared, if you look over here, 6 squared, right? Oh, this is too small now. So we'll make this big again, a little bigger. 6 squared is 36. Okay? So 6 squared is 36. If we know that, it's a perfect square, then the square root, so the opposite, we're doing the opposite. The square root of 36 is going to equal 6. Okay, so because 6 squared, I'm going to erase this, but this 6 squared equals 36, the square root of 36 is 6. Here's another example. Since 15 squared is 225, then the square root of 225 is, what would you guess? I hope you're saying 15. It's the opposite of squaring. Okay. Now, sometimes people are going to say that the square root of 225 equals 15 or negative 15. So people are going to say plus or minus 15. And a way you can represent plus or minus is right here. This sign right here is a plus sign with a negative underneath. So this is a plus or minus. Right here, plus or minus. Right there is a plus or minus 15. Because when you do negative 15 times negative 15, you'll also get 225. Okay, I'll go into more detail about that in just a second. So, but we're mainly focused on the positive. So let's take a look. Squaring and square root undo each other. So I'm going to give you a couple examples. Let's say the square root of 15, right, squared. So that's going to mean that 15 times 15 inside. These two cancel each other out. Here, let's make this a little bit more clear. The square root and the 2 cancel each other out, and that's going to equal 15. So what I'm trying to say is that the squaring and square root undo each other. They are kind of like opposites, like inverse, okay? Or you can say the square root of 4, but in parentheses say squared. The square and the square root cancel each other out. Oh, what happened? Okay. They cancel each other out, and your answer here is going to be 4. Hopefully this is making sense. The square root of 49 squared, I'll do it again. The square root and the square cancel each other out, and the answer is 49. They're opposites. And the square root of 11 squared, they cancel each other out, and this answer is going to be 11. Okay? Go ahead and box all these answers. Alright, so hopefully that's making sense to you, that squaring and square rooting undo each other. They're opposites. Okay? So here's some practice problems. Square root of 25. Well, if you look at the list, okay? If you look at the list that's, I'm guessing, above me, right? The square root of 25, this is 5 times 5. Okay? So this is another way of saying 5 squared. The square root of 25 is going to be 5. Okay? So we're trying to see what two numbers can we multiply to get 25. These are perfect squares. Okay? So the examples that I'm giving you right now are all perfect squares. Let's look at this. 16. The square root of 16 is 4 because this is 4 times 4, or 4 squared. And when you do the square root, you're going to cancel out each other. Okay? Here, a little bit tricky. The square root of 81 over 100 is the same thing as 9 squared over 10 squared. And this is going to get us 9 over 10. Okay? Let's do this one. What can we break this up? So I'm going to break this up into square root of 4 over square root of 9. It's going to be the same thing. Okay, and what is the square root of 4? Well, 4 is 2 times 2, so 2 over 9 is 3 times 3, so over 3. That's our answer. Okay, so when we have a fraction like this, you can choose to either break it up like I did right here into two different, let me use a highlighter. Oh, here, like I did with two different, okay, or you could say the square root of the whole thing, and notice that's 9 squared, 10 squared. Right here, it's also 2 squared, 3 squared. Okay, I just didn't write it out. The square root of 400. Now, this is a little bit trickier. okay? But I know that I can break up, what can we multiply to get 400? Well, I know that I can multiply 4 times 100, and those two are perfect squares. I'm trying to use numbers on this list, okay? And in my head, I knew that 4 times 100 equals 400. So that's how I decided to break this up. And this is the same thing as square root of 4 times the square root of 100. And we know that the square root of 4 is 2, and the square root of 100 is 10. So our answer here is 20. Okay. Next, 6,400. I'm going to break this up to 64. And do you know what 64 times blank equals? So 6,400? It's going to be 100. Okay, so the square root of 64 times the square root of 100. The square root of 64, let's see if 64 is on this list. Ooh, right here. So it's going to be 8 squared. And 100 is 10 squared. So this is going to be 8 times 10, which is 80. Okay, so hopefully this is making sense to you. We're breaking up these numbers to numbers that are friendly. Okay. The square root of 0.36, well, I know that 36 is 6 times 6. So I'm going to see, what can I multiply? 0.6 times 0.6. Let's see, I think that'll work because they're 2 decimal. And it's going to move over 2 times. So 36, 1, 2. So this is 0.6. 169, I'm going to think of it as 169, okay? And right here, we can see that's 13 squared. So this is going to be 1.3. 1.3 times 1.3 is going to get 1.69. Okay, so here, we'll give you some problems. 5 squared, I'm going to answer that to be 25, plus 12 squared is 144. And that's all underneath. The square root of, what's 25 plus 144? Quick. 169. And the square root of 169 is 13. How do I know that? I could look at the table. It's right there. We just did that right here. Okay, right here. Remember, square rooting and squaring cancel each other out. So, failed. Here. Bye-bye. Bye-bye. So this is going to be 5 plus 12, and the answer is 17. I want you to notice that these two are they're different answers. So make sure that you either have to get 5 squared plus, I'm looking over here, 5 squared plus 12 squared first. If they're inside, and if they're not, you have to keep them separate. Okay? All right. Number 11. Ooh, there's a 4 outside of it. That's fine. But what's the square root of 196? 196 is 14. So this is going to be 4 times 14. Okay, 4 times 14 is 615. 156. Okay. Right here, the square root of 8 times the square root of 8. This is going to be, you can multiply 8 times 8 is 64. And now we know that this is 8 squared. So this is 8. Okay. Last one, if the area is 49, so we know that this is 49. What number times what number equals 49? This is 7, 7, 7 squared. So how long is each side? 7 meters long. I know I flew by this, but I'm trying to make these notes as short as possible so that you guys are able to get through it, okay? If you have any questions, make sure that you save those questions for our Zoom meetings and ask, okay? So I'm going to end it right here.